far beyond the haze of Earth's atmosphere. The James Webb Space Telescope drifted silently in its orbital home, a million miles from our planet. It resided in the cold isolation of the second Lagrange point, untouched by terrestrial noise or motion. After years of watching the darkness, of mapping the infancy of galaxies and decoding the chemical signatures of distant exoplanets, Webb's final transmission shook the scientific world to its core. The telescope's latest, and perhaps most, extraordinary set of images arrived like a revelation phenomena, so unexpected, so visually and scientifically jarring, that researchers were compelled to reconsider the very foundations of cosmology. Long-standing assumptions about the structure and fate of the universe no longer held firm. The images were delivered in staggered bursts, each frame painstakingly filtered and composed from deep infrared data gathered over months of careful observation. Among them, one particular image seized immediate attention. It depicted a region of space once believed to be nearly empty, but now revealed an intricate lattice of filaments glowing faintly in the mid-infrared spectrum. These thread-like structures stretched across tens of millions of light-years, linking far-flung galactic clusters in a vast cosmic web. Astronomers had long theorized the existence of such filaments, but the detail captured by Webb surpassed the combined resolution of all prior instruments. Theoretical constructs had now become visible real, ancient, cold, an unimaginably grand dot. Closer examination of this cosmic web revealed strange anomalies embedded within its filaments. Concentrated nodes of energy were detected, puzzling scientists. With their refusal to conform to known thermal mapping techniques, these points emitted no light in visible or infrared wavelengths, but disrupted surrounding background radiation. Curiously, they bore no signs of gravitational lensing. Nor did they distort local space in predictable ways, as black holes would. These invisible beacons, quiet and cold, rose to immediate prominence in the minds of theoretical physicists. Had Webb inadvertently photographed exotic matter? Or were these relics of a time before the Big Bang, if such a time could even be said to exist? One photograph, more than any other, captured both emotional and intellectual imagination. It was directed toward RxJ 2436-15, swirling elliptical galaxy some 10 billion light-years from Earth. Webb observed its central supermassive black hole exhibiting irregular fluctuations, as if pulsing, almost breathing. The event horizon shimmered, not from gravitational lensing, but as if space itself were unstable at the core. Over weeks, Webb took image after image, documenting these pulses. It didn't follow known patterns and couldn't be linked to accretion disk variability. Scientists noticed a peculiar symmetry instead mere, like bursts of radiation echoing in concentric rings. It was suggested with cautious awe that the black hole might be interacting with dimensions beyond our own. A gateway? An echo? Something hinted at in the pages of string theory, now caught in the lens of a telescope, adding to the mystery. Webb's final deep field survey, aimed at one of the oldest known regions of the universe, unveiled something that defied all cosmological logic. An object whose light signature suggested an age older than the universe itself. By every accepted model, no star or galaxy should have existed before the Big Bang. Yet, this anomaly appeared as a tightly clustered mass of stars, suspended in an ancient hydrogen fog, untouched by heavier elements, untouched by time itself. Redshift readings placed it at more than 13.9 billion years old. Even accounting for measurement error, nothing in the laws of physics could reconcile such a finding. Its spectral footprint was devoid of the usual signatures: no iron, no carbon, suggesting a formation from primordial gases in a hidden, ancient pocket of the early cosmos, perhaps something that predated known cosmic expansion entirely, beyond their scientific value. The images Webb returned were haunting in their beauty. One expansive mosaic captured the death of a star in such clarity that it resembled a painting more than a photograph. The delicate arcs of expelled gas were rendered in stunning detail, each tendril tinged with subtle infrared hues, like earlier telescopes, which had offered fragmented glimpses of such events. Webb revealed every line of ionized gas, every swirl of stellar disintegration. Scientists and artists alike were captivated by this image of solar system unraveling from within, shedding its layers in slow, glowing waves across the void. In another quadrant, Webb turned its gaze toward a rogue exoplanet drifting alone in the blackness, unbound to any star. It wasn't merely the concept of a sunless world that unnerved researchers, but the soft aurora flickering along the planet's horizon. This suggested the presence of a magnetic field and possibly an atmosphere air. For such isolated planetary bodies, stranger still, Webb detected a repeating infrared pulse originating from the planet's equator. Something inside was generating heat rhythmically. Without a solar source, the energy had to come from deep within, perhaps geothermal processes, or something more artificial. Scientists hesitated to speculate openly, but the whispers were there. Could it be alien technology? A failed colony, a drifting probe, left behind in the interstellar dark. Webb also captured rapid cosmic events once thought impossible to observe. In a stellar nursery within the Carina Nebula, it recorded a burst of star formation so intense that it temporarily overwhelmed its infrared detectors. Within mere days, entire stars formed and ignited, pulling in clouds of dust and gas. Star formation is typically a slow process, unfolding over thousands or millions of years. This accelerated burst hinted at unknown forces at work. Some hypothesized that supermassive gravitational waves left behind by ancient galaxy mergers might be triggering these events. Others wondered if dark energy fluctuations were responsible, altering local space-time enough to catalyze stellar birth on unimaginable timescales. Perhaps the most emotionally stirring image of all came not from deep space, but from our own solar system. As part of its final calibration, Webb turned back toward the outer boundary near the hypothetical edge of the Oort cloud. There, captured a massive object gliding slowly across the backdrop of stars. It may have been the long-theorized planet, an enormous body, many times Earth's size. But this wasn't just a cold gas giant. The patterns on its surface defied expectations. It didn't look like a typical ice planet either. Despite being relatively close in cosmic terms, this object had evaded detection for centuries. Now Webb's sensitivity had pierced the veil, and the implications for planetary science were immediate. Our own solar system, it seemed, held mysteries as profound as any galaxy. Some of Webb's most surprising discoveries didn't involve stars or galaxies at all, but the space between them. Regions once thought to be inert and lightless revealed strange fluctuations in the cosmic microwave background. These ripples weren't predicted by inflation theory. Even more perplexing, Webb identified localized pockets of negative temperature as colder than the theoretical vacuum of space. Such findings challenged our understanding of the universe's post-Big Bang uniformity, theorists suggested. Interactions with quantum vacuum fluctuations, or the fading touches of alternate universes brushing against our own at cosmological boundaries. What truly set Webb's final photographs apart wasn't just their clarity, but their temporal depth. Each image acted as a layered window into the history of the cosmos. The telescope's infrared capabilities allowed scientists to peer back across eons, watching as matter assembled itself in a universe that was once chaotic and full of unshaped energy. But something strange emerged from these studies: an asymmetry in galactic formation. Galaxies that should have formed in balanced symmetrical patterns instead appeared distorted, as if nudged by unseen forces. Some had unexpected spirals, while others contained vast, hollow core voids not created by black holes, but by some unknown repelling force. Among the most mesmerizing images was a mosaic, showing two titanic galaxies mid-collision. Rather than the expected chaos, the galaxies appeared entwined like cosmic dancers, and at their point of intersection, something astonishing was taking shape: a crystalline structure of stars and gas, arranged in a geometric lattice with perfect symmetry. Researchers were stunned. Was it natural? A new gravitational dynamic? Never before observed? Or had Webb captured something far more profound, evidence of intelligence operating at galactic scales? As the images made their rounds through labs and observatories, they sparked not only analysis, but awe. Each pixel held secrets. Each filament of light challenged what we thought we knew. And in the silence of space, far beyond Earth's haze, the James Webb Space Telescope had spoken one last time its voice, not a signal, but a vision, quiet and eternal.